Good afternoon, all of you. Thank you for coming to the presentation. Today we would like to talk about the modeling economic implications of short-term object management strategies and water scarcity. So this study is centered at the Goulburn Local Catchment. It's one of the Australia's premier fruit growing regions. The extent of orchard in this region is 1,600 hectares and around 650 properties. The principal orchard crops in the region are pears, apples and peaches. They're mainly grown for fresh food market and processing through canneries. The normal irrigation season is from September to April because these are perennial crops. The rainfall is not sufficient to fulfill crop water requirement in certain months, so it depends on irrigation. But in the recent past, the reduced water availability, not very recent past, but the recent past, the reduced water availability and possible climate change and other competing uses like environment, water for environmental priorities, the water stress. But unlike sort of dairy industry or other crops, as far as orchards are concerned, water scarcity has a two-dimensional impact. It affects the yield as well as the quality, especially the size of the fruit. It comes down when the plants are subject to water stress. But in this region, the Goulburn Local region, most of the orchards are micro-irrigated using micro-jets or mini sprinklers, and the irrigation technology in the physical infrastructure side is, we can say, relatively efficient. There's a minimal conveyance losses and the soil evaporation is less. So we aim to examine the economic implications of water availability under strategies aiming to reduce consumptive water use and maximizing water return through manipulating the crop load. Crop load means number of fruits in the tray. So we're trying to use two technologies in combination. One is manipulating the crop load through thinning, and another one is applying reduced amount of irrigation water in certain time of the irrigation season. According to the studies, there are periods in the perennial crop growth cycle where water stress would not affect the crop yield and fruit size. So there are we examine 4 types of technologies. Like if you take that, this is the period where the fruit growth is low and shoot growth is high. So during that time, we can reduce the amount of irrigation water applied and still have the same fruit quality and quantity in terms of this is known as the regulated deficit irrigation. And the second one, the post-harvest deficit irrigation, is applying less amount of water after harvesting the fruits. And deficit irrigation is applying low amount of water throughout the irrigation season. I will show that in the next slide. But this graph is not existing in the apple crop, unfortunately, because in the apple, fruit grow throughout the season. So the regulated deficit irrigation can't be applied to apples. Now, the parking the tree is a strategy. Remove all the fruits from the tree because fruits cause the 25 to 50% vapor transpiration losses from the tree. So after removing the tree, apply only 30% of the water throughout the season. So the purpose, what's the ambition for the aim of doing this is anticipating the good weather in the next season and to conserve the trees is the purpose of this strategy. And you can see that the yellow line is the full crop water requirement. We are applying, fulfilling the 100% of the crop water requirement, and the red ones are the post-harvest deficit, and the purple one is regulated deficit, because here we are applying low amount of irrigation water even in the month of November. But the dotted lines are deficit irrigation strategies, and green one is parking. So, water profit function. We use water profit function to capture the yield quality trade-off in orchards. The fruit size is a major quality aspect to determine the market value of orchard fruit. The other key quality parameter is sweetness. According to the scientific studies, it is told that sweetness is not affected by water stress. The relationship between the fruit size and crop load. We adapted the linear function between reduction of fruit size and crop load. The linear negative relationship between levels of thinning and fruit weight has been demonstrated in many studies. Yes, the Bound 2005 is a study conducted in Tasmania, and Palmer's Italy is a New Zealand study. And the relationship between fruit size and water stress, we captured fitting a logarithmic function to the experimental data, locally available experimental data. Experiments have been conducted in Tatura. To indicate the intensity of thinning, we use the normalized number of fruits per tree is used. The 100 indicates the complete removal of fruits. 100% of fruits have been removed, and 0 is no thinning is done. So, to determination of the optimum fruit size and crop load depends on market prices of various fruit grades. The fruit grade price information. For apples, we were able to source very good information from Montague apples. But for peaches and pears, we couldn't get information from one source. So we used the size specifications from Coles supermarket and the product description language from APAL, Australian Pear Apples Limited. For pears and peaches, we use the prices from Melbourne wholesale market. So the size and price are coming from two different sources. That's the best we could do. And other thing is, having spoken to the extension people, as far as pears and peaches are concerned, the grading is not that finer. Like in apples, the grading is very much fine, and they have many grades. The distribution of the fruit size. The crops resulting from different levels of thinning comprises various grades of fruits. Therefore, because by thinning, we can't increase the fruit size. Actually, what we are doing is by thinning, we are increasing the number of proportion of larger fruits. So, therefore, income is determined by the distribution of entire fruit size at the harvest, not just the mean of the fruit size. The fruit size distribution is assumed to be normal with 20% of coefficient of variation for varying means of simulation. I will be showing that in the next graph. Here, you can see that in this graph, when the mean is lower, there's 110 grams. Most of the fruits are in the small fruit size range. So this simulations has done for each mean by fixing the coefficient of variation 20 for 100,000 times. The results have been categorized into grades, the specifications that we obtained from Montague apples and Coles. So this is a water profit function. You can see that in apples, when the level of thinning is at medium level, it gets higher prices. The reason is not only higher yield. In case of apples, the medium-sized apples get higher market price. It has been revealed in another study as well in 2003. Hester and Kajo did a study. Their study also found the medium-sized apples get better market price.